Hello, everyone. Thanks for joining me today to talk about how to use player data to build better games. My name is Arni Birgisson. I'm a developer advocate at AWS, and I have a focus there on game tech specifically. I've been with AWS for coming up to 4 years. Most of the time, actually, I've spent as a solutions architect working with games customers and game studios and publishers. But this year, I took on the role as a developer advocate, and well, that's kind of why I'm here. Prior to taking on that role in AWS and the solutions architect role, I've worked in infrastructure and networking and game dev and backends for the most part. So in today's session, we're going to be talking about data and data collection. And we're going to be talking about the importance of using data to see player behavior and to really be able to make better decisions and make better games. And we're going to talk about how some of the customers at AWS are doing that, how they use AWS to build their analytics pipeline solutions. And perhaps most importantly, we're going to be talking about why. Why do you do analytics? Why is it so important? And really, how can you get the most value for your time and for your effort? Now, last, I'll talk about the games analytics pipeline solution, which is a template that we have that allows you to really get started incredibly quick, and really kind of build your own pipeline or use it as a base to modify and kind of grow from there. And essentially, my hope is at the end of the session, you're going to walk away with a better understanding of what's possible and what are the first steps that you have to make towards having analytics in your game. And so let's start with the why. Games customers and games studios and publishers, they put a large emphasis on having a robust data collection and analytics pipeline set up for their titles. And in my role, when I'm talking to game studios and publishers, kind of wherever they are in their journey, they're thinking about analytics. So whether they're taking the first steps, they're ideating about a game, or even if they're well on their way into launching a game into production, they either have already set up an analytics pipeline, they're using maybe an outsourced vendor for analytics, or they're thinking about how can they set one up themselves. But everybody's thinking about analytics. And that choice perhaps between creating your own or running it yourself or kind of outsourcing to somebody else, mostly comes down to whether you have the capacity to design it and to operate it yourself. But it also has to do with the ownership of the data. And by leveraging a platform like AWS and building your own pipeline, you definitely have full control over the data and over the pipeline. But again, let's start with the why. Why is analytics so important? And what's the goal of analytics? As you're developing a game, it's really important for you to have the right information at the right time to be able to answer questions about how your game is performing and kind of what changes you need to make to keep the players happy or keep the players engaged. And it's all about creating engaged games. And having that information at hand, and if you're able to answer those kinds of questions, that will allow you to iterate more quickly and to provide ultimately a better experience for the players. And this is especially important because games are today transitioning from this one-time purchase model where you buy a DVD or a Blu-ray disc and so on, into this as a service model where it's either a subscription or it's DLCs or it's free to play or transaction-based and so on. And companies typically continue to invest in their games long after launching them, right? So when you got the gold master, that's not the end of it. And companies continue to make modifications to the gameplay and really to balance the gameplay based on data from the players and from the usage. Now, data collection and analytics also plays a role in fraud detection and being able to find unusual behavior by comparing the behavior to what would be, well, usual or normal behavior, and also to detect cheaters. And if you think about it from an infrastructure level, if you're able to monitor and really kind of see the performance of the game from the player's device or from the eye of the player, then you're able to catch errors and performance issues as they happen, and often really before the users even notice that anything is going wrong. So it plays a number of different roles. Now, the purpose of an analytics pipeline is really to help you achieve this by making the right decisions. And we often view this as a flywheel. The more data that you have is going to give you the opportunity to create a better design. And a better design will, that could mean better levels or better balance or better weapons or, better maps. But that'll lead to a better experience for the players. And a better experience for the players results in the players being more engaged, they play for longer, they play more sessions, and they may maybe pull their friends in and so on. So it spreads the game more. And more players and more sessions and longer sessions and all of those things obviously in turn gives you more data. So it kind of takes you a full circle around the flywheel. And one of our customers, Supercell, they shared this great quote with us about their analytics. And Sami Iliharju, who's their services lead, he said that they collect data because their games don't stay in the top 10 lists automatically. They earn the success by really listening to the community and the players, by providing additional features and balancing the game to make it fair for everyone. And I think that sums up really well how you're using analytics to really make a better game. So, I've said data quite often now. What kind of data are we interested in? What is useful information for us to be able to build better games? Now, in most cases, you're going to be interested in what your players are doing, the gameplay mechanics, and then business metrics. And there could be other categories as well. And so here's a few examples. What your players are doing can be things that even in a multiplayer online type of game, you could only see from the client side. And so let's go through a few examples here. You have obviously sessions, right? The opening up of the game client, starting a game, ending a game, kind of starting a session, and so on. Excuse me. Then you have the progression. So how are players progressing through the game? Have they just installed the game? Have they gone through the tutorial? Have they maybe finished the first couple of levels? Have they passed the first boss, or progressed through the first quest, kind of depending on what kind of game it is. And then there's the player's location in the game. And the location in the game isn't like where you are on the map. It's more where are you in the game? So are you currently in the lobby? Are you in the chat? Or are you viewing something in the store? Or are you actively playing a game session? So kind of where are you located in the game? And that kind of information is often something that you can't really see from the server side. You can only see that from the client side, because the player could be scrolling up and down or something in the game, and that doesn't really send any calls to the server. And then blockers, or anything that kind of prevents the player from playing. So it could be crashes, it could be if they're unable to install an update or unable to log in or something like that. And then you want to be able to validate the core mechanics. So those are things like the gameplay itself, player decisions. For example, if you have a class-based game, it can be a warrior or a mage or a sorcerer or something like that. It's interesting to collect that information as well. What classes are being picked, and is there maybe a correlation that you could look into the future between which classes are typically the ones that win the game or something like that? You could look into, whether, non-player decisions as well, right? The performance of the game or the performance of the servers. Obviously, you can measure those things on the servers. But if you think about it, really, a thing like latency, for example, the only latency that really matters is the client's perspective. How much latency is the client seeing? And so collecting that information from the client is very important. You could also measure things there like infrastructure issues, like internet service provider outages, inability to connect, and things like that. And then from these metrics, you can also derive other metrics like business metrics. So things like daily active users, which is typically how many unique users have connected into the game in a 24-hour period, or how many weekly active users. You can look at monetization. Out of all of the people that are being shown a particular upgrade, or they could unlock something, or they can buy something in the store. People are being shown maybe video ads, how many skip over them, and so on. These are things that you can measure. And with all of these events, there's a standard set of information that you should always include as well. And that is, if you know who the user is, so if they're logged in, then some handle, so the user ID, what's the action that they were performing. There should be a unique identifier on the event, so that you can more easily deduplicate if events are sent more than once. And there should be a timestamp. So from the client's perspective, when did this happen? Because it might take a little bit of time for that to kind of get into your system. And there could be other metadata and other kind of basic information that you would always include as well. Now, it's important to know that when you're working with all of this data, that you need to derive insights from it, that the data really has a shelf life, and data really loses value quickly as time progresses. And certain time critical decisions, they really need the data to be real time or very close to real time. And traditionally, much of the analytics that has been done was more on the reactive or historical side. But with these kind of transition into online services and this constant evolution, there's a lot of value in having the ability to gather these insights as close to real time as possible, because it allows you to reduce the time that it takes to fix issues or make really important changes quickly to retain the players and really improve the experience that they have in the game. Now, I've talked about a number of things that could be interesting to collect, but you should really take care to think about which data matters to you and what are the questions that you're trying to answer. And then from those questions, kind of work backwards to be able to answer that question, what's the data that I need? And so one of the ways to do that is to think about this, kind of backwards thinking, to say, let's formulate a question that we want to find an answer to. And then we can create a hypothesis. What do we think could be an explanation, or what do we think could be the answer? And that might help us lead us to knowing what data we need to collect to be able to answer it. And from there, either validate or continue experimenting until we find the answer that we want to. But it's important to not just collect everything, not just collect whatever piece of data is available, because that'll end up to being pretty big, pretty fast. So you want to be able to know kind of what are the questions that you're trying to answer, and what's the data you need to be able to answer them. And so, I'll take an example here, and I use this example often. It's from the game Breakaway. And we have some questions that we're trying to get answers to here. And sometimes we have to think a little bit beyond the obvious questions. So a question like, does the user like the game, is very hard to know without basically just asking the user, do you like the game? Or a question like, how can I avoid people leaving the game? It's also a very kind of open-ended question, and it cannot really be answered directly with data. So it needs to be broken into something that you can really measure, and measure it from the actions or the inactions of the player. So let's come up with a hypothesis here, and let's try to see if we can do something here that makes a little bit more sense. So in this game, this is a map that's called El Dorado in Breakaway. And it's a 4v4 team battle arena game. And at the start of the game, there's an object that's called the relic that's in the center of the map. And each team tries to take the relic and carry it to the opposite team's starting point, which is called a relay. And on the sides of the map, you can also see power-ups that you can pick up as well. And so as you look at this map, you might form a hypothesis that for a balanced gameplay, that you'd want a certain distribution of where people are hanging out on the map and where they end up being killed, or like where do deaths happen on the map. Occasions where that happens is distributed around the whole map, then perhaps the map is lacking variety and maybe lacks something that makes the players interested. Likewise, if all of the deaths would be happening in exactly the same spot or around the same spot, then maybe the map isn't interesting enough to explore the whole map, and players kind of just end up camping around that one position. And so we ask a question here, and we form a hypothesis. We say most of the deaths are going to happen in the center of the map where the relic is, and where they kind of try to run and grab the relic. Some deaths are going to be around the power-ups as well, because people are grabbing the power-ups. And you can also follow the edges of the map. So these are the things that we kind of expect for this to be a good map, and kind of according to how we wanted to design it. And then to be able to answer that question, is this correct? We need some data. And here's an example of what data we could collect for this. So in that little kind of JSON screen there, you see an event ID. So there's a unique ID for this particular event when something happened. What happened is a player death, so that's the action. There's a timestamp when it happened. It's arena is which map are we playing, and the position is where I am on the map. Right? So this is all the information that I need to be able to get to the answer to my question here. And the team behind Breakaway, they created an app to generate a heat map from this data, and they have this data in Amazon Redshift. And the map shows concentration of the deaths. So kind of the lighter the color, the more deaths are happening there. And this is a 2D top view of the map that we were looking at before. And there's a SQL query that aggregates all these events and concentrates them to little blocks that are 1 by 1 meter, or cells that are 1 by 1 meter. And so the question is, where are the deaths happening? Now, this is something that we can very easily answer directly, right? And so our hypothesis was that most of the deaths are going to happen around the center of the map, where people are trying to grab the relic. And there are going to be also deaths around the power-ups on the sides, and then some around the edges of the map if you fall off. And now the conclusion is that there's a lot of deaths that do occur in the middle of the map. So we're kind of correct there. And there's a good amount of color also outside of the arena that indicates that people are falling off the edges or they're getting pushed or something like that. So it's kind of according to the plan. But the power-ups actually are there's very little things happening there. And so that's interesting. That's not what we expected here. And it could mean that possibly players don't find them valuable enough because you're very exposed when you walk up there. And so they just don't go there. And you might need to make them more powerful or more interesting. So this is an insight that we're getting here from this information. And if you look at this pseudocode here is the query that creates the map. So you're taking the floor of the position X and Y, essentially just to squash it down to 1 by 1 meter cells, and then you're counting those from those game events, for this particular map where the event type is player death, and so on. And that's how you get the data for this. Now, there's another interesting thing as well, which we didn't expect, and it's those 4 corners there. So the power-ups were kind of less popular, or like fewer people were dying around the power-ups, but there's a lot of deaths that are happening around those 4 corners that they seem especially dangerous. We don't really know why. Perhaps people are camping around those corners or something like that if you can't see around them. But this might help us ask another question, come up with another hypothesis. Why is this happening? Is this maybe a good thing? Is this emergent gameplay, which people typically like? And essentially, without the telemetry and without the analytics that we're doing, we wouldn't have known any of this. So let's look at what a typical analytics pipeline looks like. So on the left side, you have telemetry or events. Those are things that are being sent into the analytics pipeline for processing, things that are happening. And that's just data, right? Then on the right side, you have the metrics. You have the answers that you're trying to get to, the answers to the questions, essentially. And so an example of telemetry or the event is this JSON kind of structure that I showed before. And an example of the answers that come out of the pipeline is the map that kind of answers some of our questions here. And if we look inside this pipeline, these are typically built in kind of 4 high-level steps. So the first step is to be able to ingest or collect all of the data, right? Data is coming from clients that are playing the game all around the world. It could be also coming from the servers. It could be coming from additional services that you have outside of the multiplayer servers or the gameplay servers. So it's kind of coming from all directions. Then you need to be able to store this information somewhere because you want to be able to come back to it later. And you want to be able to query, run reports, answer questions, and so on. In addition to that, there's typically like a processing or an analysis step where you are taking some of that data and you're processing it or transforming it to make it essentially better for future work. So this typically involves, for example, switching the format of the data from this JSON structure, which is very nice to read for humans, but it's not great for computers, and changing it into something more performant like Parquet or ORC or something like that. You could also be doing some kind of real-time analytics there. So as soon as the data is coming in, you're already kind of analyzing some parts of it. So that could be to run a dashboard, for example. You have a dashboard with how many people are playing the game, or what's happening in the game, or something like that. Yeah, essentially, yeah. And the last step is obviously you need a way to be able to consume the data or visualize it. So you need something that can connect into this big collection of data and get something meaningful out of it to show, some dashboards or graphs or something like that. And typically creating something like this has been very hard. There's a lot of components. It's tricky to scale it, and it's hard to achieve the high availability. You want to be able to collect all of these events and all of these things that are happening, and you don't want your system to, drop down or be overloaded or so on. So this is something that has been traditionally pretty difficult. But with AWS, it's been a core focus of ours for multiple years to make creating things like this and having services in place very easy. And so if we kind of skim over the portfolio of services that we have for analytics, it's essentially a full suite of services for analytics, and it allows developers to really just focus on developing and building the applications and the games, and not managing the infrastructure. And it includes, business intelligence, machine learning services, various analytic services and database types, as well as services to store and move data. And we both have, pre-existing deployable solutions, and I'm going to talk about one of those that you can deploy yourself and build kind of using these building blocks and these components, or you can combine them in any way you need. And there's also AWS partners that provide these kinds of services and can build this for you. Now, this is very different, as I mentioned in the beginning, from just going for like a complete packaged analytics offering, because with this approach, you're totally in the driver's seat for how do you want the pipeline to be designed, who owns the data, who can access the data. All of that is very clear in this, that you are the owner of the data, you control who accesses it, you design it the way you want it, and so on. And you can use pay-as-you-go services. And AWS services are typically pay-as-you-go. That means that you only pay for what you use. So you pay for the components and for the amount of data, and you pay for the things that you're using. And you don't have to make large upfront investments in hardware or data centers or infrastructure. Now, let's go through how could you assemble these building blocks in a way that works for you. And I have a number of examples about this, but typically these pipelines, they start with a Kinesis or Amazon Kinesis data stream. And Amazon Kinesis data stream, my next slide is about Kinesis, but this is the typical ingestion mechanism that allows you to take in all of these events. So all of the events can be sent to Kinesis, to a data stream, and from various sources. And what are those sources? So typically, the game servers or the backend servers are one, and the game servers and the backend servers, we view them as an authoritative source of data, because typically you've authenticated, you've connected into the server is making all of the calculations of what's happening and so on, so you can trust those events. And typically those events get sent directly from the game servers or the backend into the data stream. That's a little bit different from the game client. And here we are looking at a mobile game client, because a mobile game or a mobile could have been hacked or changed, or something could be happening to the traffic on the way and so on. And it's harder for you to trust the data that's coming from the client than it is to trust something that's internally coming from your servers. And so typically the mobile game, you want them to authenticate, and you can use a service like Amazon Cognito for authentication. And you want to verify that that data kind of looks right, and so on. You could also use to use the sending this directly to Kinesis from the mobile client, as the kind of top approach is, that it requires you to have an SDK in the client. And if you don't like including an SDK in your client for some reason, if you're limited on space or something, you can also use an Amazon API gateway in between there. And then the mobile client can just use standard web requests and a REST interface towards the API gateway, and the API gateway will forward it to the Kinesis stream. But so there are different ways that you can get the data from the clients and the servers into the data stream. But you want to kind of get all of this data into a stream. And then if you look at the right side of this diagram, that's where you kind of start analyzing the data that's coming in. And so one of the first things that you want to do there was to store, right? So this is the ingestion part, and then you want to collect and you want to store those things. For that part, we have a service which is called Kinesis Data Firehose, or Amazon Kinesis Data Firehose, which takes a data stream from Kinesis. It can compress it. It can batch it up into larger blocks, essentially, and then ship them over to Amazon's Simple Storage Service, S3. And then you've already kind of taken that data, those events, all the way into a safe and very affordable and economic storage, which is S3. Now, if you're mostly thinking about storing the data for the long term and doing kind of batch analysis, doing ad hoc queries, and so on, using a service like Amazon Athena, then you're essentially done at this stage. Right now, you've assembled all of these components. And in this diagram, there are no servers for you to manage. There's no operating system patching, updates. There's nothing like that in this image. These are all services that are fully managed for you. But if you want to go a little bit further, you could also have a more of a real-time analysis on the stream here, having, for example, a Lambda function that takes the stream as it's coming in, looks at the events and updates, for example, a DynamoDB database that will feed a live dashboard. So this could be something like, every time that somebody starts a new game, you could kind of increase a counter for the number of games that are being played. Or anytime a team wins, you could kind of update a counter for how many times has that team won, and you could have a live dashboard of which team is winning the most. So these are kind of more live data happening on the stream. And then you could also use Amazon Kinesis data analytics, which allows you to write SQL queries on the stream. So you can do kind of live or windowed aggregations, summarizations, averages of the incoming events, and then you could react on that in various ways. So this is a very kind of typical pipeline. It has these kind of ingestion, the collection, the processing, and then the visualization and consumption of the data. And Kinesis, or Amazon Kinesis, tends to be the centerpiece there in this collection. Now, Amazon Kinesis allows you to easily collect, process, and analyze data in real time. And it comes in these 3 different versions, which we touched on briefly. So Kinesis Data Streams is the core service. It allows you to create a stream, set the capacity that you need in terms of how many messages per second you need to process, and it performs continual processing using the Kinesis client library or Apache Spark or Lambda or more, so you can connect various things to a data stream. The Kinesis Data Firehose is a zero administration way for you to take the Kinesis data stream and then deliver that compressed in a good format, batched up into either Amazon S3, Amazon Redshift, or Elasticsearch clusters without writing any application code. And Kinesis Data Analytics allows you to analyze the streams in real time using SQL queries, some standard SQL, or you can use Apache Flink. And you can connect that into a Kinesis data stream or a data firehose. So you can kind of mix and match these a little bit. Now, I'm going to quickly kind of show you the analytics pipeline for Fortnite from Epic Games, which is an AWS customer. And just to kind of show how these analytics pipelines typically look, because they often look very much the same. So on the far left side here, you see the game clients, the game servers, the launcher, the game services. All of those send their events into Amazon Kinesis. And then from there, it splits up into a kind of a near real-time pipeline, which is for these, Grafana dashboards, scoreboard API, and things like that. So more real-time. And then a batch pipeline, where they're using Amazon S3, a number of databases, Elastic MapReduce, and other services to kind of make that data available for reporting and analysis afterwards. Now, for Epic Games, they use their analytics pipeline for everything from service health, detecting outages of internet service providers, to validating tournament results, giving prizes and KPIs. And to achieve that, they are doing, well, this is actually a little bit old. This is from reInvent in 2018, where they shared this information. So they were doing 125 million events per minute, 79 billion events per day, 60 gigabytes per minute of data, right? These are huge numbers. And they're using Kinesis, in 5,000 Kinesis shards to be able to do this. And Kinesis shard is the scaling kind of unit in Kinesis. At the time when they shared this, their data warehouse was over 35 petabytes, and they were adding 5 additional petabytes per month. So pretty interesting numbers, but this is based on the same set of services that's available to all of our customers, whatever their size is. And so this just kind of gives you a little bit of an idea, how far this can scale, both up and down. So what's the right approach for you to get started? Depending on your needs and the size of your team and the expertise that you definitely have a few options here. Now, I've talked about the building your own part. I've talked about like some of the components that you need to build your own analytics pipeline from scratch. And you can use the breadth of services that are available at AWS, and you can really tune it to your needs. You can also start from a reference architecture. And the architecture that I showed you before, where you saw the 3 different ingestion methods, the Kinesis data stream in the middle, and then the storage part, and so on. That comes from a serverless analytics pipeline for mobile games, reference architecture, which is available. You can download it, have a look at it, and you can kind of build from there. And then there's also a deployable solution, which is called the Games Analytics Pipeline solution. And that's a fully deployable template that you can take and deploy. It's open source. You can modify it and kind of make it your own. And that gets you started in literally minutes. And I'm going to show you that a little bit, what that looks like. So essentially, the Game Analytics Pipeline solution was created by a team of solutions architects and technical account managers that work with some of our largest games customers on a daily basis. And it includes everything that you need to get started. So including a CloudFormation template, which is an infrastructure as code template that you can essentially take and deploy to get a copy of that pipeline. It also includes a deployment guide, a reference architecture, and a developer guide, which takes you through, like, if you want to make modifications or if you want to kind of do something a little bit differently than this solution does, then you can change it to your needs. And like the architectures that we've looked at before now, this pipeline covers the streaming data ingestion, so ingesting streaming data, loading it into a data lake in S3 in an optimized format. It covers custom real-time metrics and alerts using streaming SQL queries with Kinesis data analytics. It integrates with AWS Glue for data cataloging and ETL workflows. And you can directly, when you've deployed it, you can directly start exploring the data using, for example, Amazon Athena and QuickSight or other tools. And you can use also open source tools, third-party tools. This is compatible with a number of different things. The architecture, I don't think I'm going to spend too much time on that because we've seen now already many similar architectures. But this is what is deployed if you deploy the Game Analytics Pipeline solution. So you can see, all the way from the left side where you have the producers of the data, the producers of the events, and then kind of how the data flows through these streams and different ways of analyzing, and all the way into the data lake in S3. And then you can see on the far right side that there are different ways of also consuming that data. So you might have live ops consumers, service teams, data engineers, and data analysts that are utilizing different parts of the system to get the access and the data that they need. It's also interesting to note here that all of these services that you see in this diagram are fully managed or serverless. So actually, in all of this pipeline here, there are no servers for you to log into and update and worry about patching and so on. This is a fully managed and serverless architecture. Now, if you're interested in knowing more about that, you can view the AWS Solutions library to learn about the Game Analytics Pipeline solution, and you can view the deployment guide. The deployment of the solution takes about 5 minutes, and since it's deployed using an open source CloudFormation template, as I said, you can easily review what is being deployed, and you can experiment, you can remove parts or add parts as you see fit. And when you're done experimenting, you can just delete the CloudFormation stack that's created, and that means that all of the components that were created get removed, and you don't incur any costs. And I think, I wanted to show you also the sample data generator. So the solution comes with a data generator for you to be able to try it out if you don't have a live game that has live events coming in. And so this data generator, essentially just a little script that sends example events into the deployed analytics pipeline. And so the script takes a few parameters. It's all in the deployment guide, but it takes basically the name of the pipeline, the application, so the ID of the game or the ID of the application, and it's game-specific telemetry, right? So it includes, it kind of creates random client IDs, random users, random servers, clans, matches, and sessions, and sends a number of different events with a variation of those things for you to be able to look kind of what would that look like, and how can I make use of that kind of data. And it also comes with a set of sample queries in Amazon Athena to help you really kind of instantly start analyzing this data using Athena. And so if this is readable enough, you can see here an example query that's extracting and summarizing which country the players are playing from. So it's kind of fetching that from the individual event data. There's a country field, and it's summarizing that. In this example, generated data, most of the players are well, no, it's not sorted, but 587 coming from the United States and so on. But this is all random data, of course, and just for you to kind of get a feel for what the data looks like and how you could do something yourself like that. For those that don't know Amazon Athena, that is a service that allows you to write a SQL query like the one that you see here without running any servers. And Amazon Athena will take that query, analyze which data it needs to be able to fulfill or to be able to calculate that answer, and it'll fetch the right files from Amazon S3 directly. So whether those files are in CSV format or JSON format or Parquet or something more efficient, Amazon Athena will fetch the right files and then open up the files, look at the data, do the querying, give you back the results. And there's no service for you to manage there. So just a query directly onto files in S3. It's extremely powerful. So maybe to summarize a little bit, what have we learned or covered today? I think first and foremost, it's important to understand the importance of data in making decisions, and how can you collect the right data the data that you need to be able to find the answers that you want. And we've talked about what are the main building blocks in analytics pipelines and how you can use the AWS portfolio services to support games of literally any size. We've seen a few examples about our customers at AWS here, some reference architectures and how some customers are doing their analytics workloads. And then we looked at the game analytics pipeline solution, which you can deploy and test in a very short amount of time, and then use and evolve and base your pipeline on that in the future. And so here's a couple of links for you. I'll leave them around for a minute. So there's a link to the game analytics pipeline solution if you want to take a further look at that, look at the deployment guide and kind of get a feel for what that would look like. And there's also a serverless analytics for games self-paced workshop that we have. So if you follow that link, you're able to go into that workshop and kind of at your own pace in your own AWS account. It takes you through how do you set up these components, how do you link them all together and get to the answers that you want, essentially. That's it for me. I'd like to thank you for joining my session today. I hope you learned something new, and I really hope that you're inspired to take the next step towards using data to build better games. Thank you so much.